Hi everyone, in this video we are going to be talking about similar triangle proofs. So we should have already established that triangles are similar when corresponding angles are congruent and when the corresponding sides are proportional. So we're going to fill those two blanks in, that corresponding angles are congruent, corresponding sides are proportional in similar triangles. There are three different ways to prove that triangles are similar. The first is angle-angle, or AA. The angle-angle similarity theorem basically says that two corresponding angles are congruent to one another. We should also understand, though, that if these two angles are congruent, that this third pair up at the top here, those are also going to be congruent because we know that the sum of the interior angles in a triangle is 180, so those will end up being the same too. So we are going to use angle-angle in a proof, but just realize that angle-angle-angle is also kind of implied from that. Then we have side angle side. So side angle side means that you have two sides that are proportional and you have the included angles, the one in between those sides, as congruent. So we can see here that 8 and 4 and 6 and 3 are proportional because if we cross multiply them, we get the same value. And the included angle is congruent, and we see that marked off. The third option, side, 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 would mean that all three sides are proportional to one another. So if I add in this third side here, we can see that these are all equivalent to one another. You could identify that by two ways. You could take any two and cross multiply the proportion, or you could reduce them. 5 over 2.5 is 2. 8 over 4 is 2. 6 over 3 is 2. And we can see, okay, they all share that same proportion, the same ratio. So let's look at a couple of sample questions here. Before we do that, we're going to also be doing some proofs in this lesson today. In similar triangle proofs, you may also have to show that corresponding sides of similar triangles are proportional. We're going to abbreviate that as CSSTP, or that cross products of proportions are equal. So when we get to some problems like that, we'll talk a little bit more about that. But first, let's just establish that there's angle-angle, side-angle-side, and side-side-side. So let's look at questions 1 through 4. They each have the same directions. Are the triangles similar? And if our answer is yes, by what method are they similar? Okay, so let's look at number 1. I see that all three sides are marked off. Okay, but that doesn't necessarily mean it's side, side, side. I want to make sure that all of the sides share the same ratio. And they do, in fact, share the same ratio, that it's all a 2-to-1 ratio from the larger triangle to the smaller one. So this is yes, they are similar, and by side, side, side. Okay, number 2. Are the triangles similar, and if yes, by what method? All right, well, it looks to be side angle side, but let's verify the ratio. So the sides that are labeled 8 and 12, GF and JI, those are corresponding. And FH and IH are corresponding, the 6 and the 9 here. So let's say I cross multiply this. I get 72 equals 72, and that works out. So the sides do share the same ratio. So yes, these are going to be similar to one another by side angle side. Number 3, are the triangles similar? If yes, by what method? This one looks like side angle side. It looks like one of the examples we saw at the top of the page, but let's check the ratios. If I cross multiply here, you're going to see that I get 20 is equal to 18. That is not true. So that means that these sides do not have the same ratio. The sides are not proportional. Therefore, it cannot be, they cannot be similar triangles. So our answer to this is no. All right, and number 4, are the triangles similar? And if yes, by what method? So same directions as the other questions. So there's 2 triangles here. So let's take note of that. And they're kind of overlapping. So here's one triangle. And then in blue, I'm highlighting the other. So just so we can focus on what we're looking at. Well, these angles in the bottom left, or I could pick the ones in the bottom right of each triangle, those are congruent to one another because those are what's called corresponding angles. Corresponding angles are formed when parallel lines cut by a transversal, and corresponding angles are always congruent to one another. I also noticed that both triangles, and you can look and see how I highlighted it here, the pink and the blue one, they both have this angle at the top in common. That angle is obviously going to be congruent to itself, right? Anything is congruent to itself, and that's by what's called the reflexive property. So in this question here, are the triangles similar, and yes, by what method? Yes, they are similar, and that's going to be by the angle similarity theorem. But you're going to see in a second that we're going to look at a proof with this same diagram so you could better understand the use of corresponding angles and reflexive property. All right, let's take a look at that proof. If at any point, since proofs are a lot of writing, you need more time to copy things down, of course, pause the video. So I've already gone ahead and wrote the givens here just to save some time. So I have my statement reason column. I know that A, B, and D, E are parallel to one another, just like they were in question 4. And that means I'm going to end up talking about the corresponding angles. If this picture is difficult for you to look at, what you could also do is draw your own picture off to the side. Doesn't have to be drawn accurately. And you can see the corresponding angles here. All right, so here's how we're going to write about it. I'm going to say that angles CDE and angles CAB, those are the two angles we're talking about, are corresponding angles. I could have also picked the ones that have vertices at E and B. I just happened to pick these on the left. You could pick both sets if you wanted. My reason for that is going to be that parallel lines, right? We knew we have parallel lines from the givens. Cut by a transversal, form corresponding angles. But our goal is to show angles are congruent, so I'm going to add an additional line here and say those two angles, CDE and CAB, are congruent, and that's because corresponding angles are congruent. Once I have that, I'm just going to zoom back out. And I know that we're trying to find a way to prove that these triangles are similar. When you're doing a written proof like this, all of the ones we're looking at in this video are going to be using angle, angle. So I know I'm looking for another angle here. We saw that even in question 4. And so I'm going to say that angle C is congruent to itself. You could see that nicely in the separated picture as well, that it's in both of them. So I'm going to say angle C is congruent to angle C, and that's by the reflexive property. Well, now if we look at both of the triangles, they both have two congruent angle markings. So I can go ahead and write my proof statement that triangle CAB is similar to triangle CDE by the angle-angle similarity theorem. All right, let's take a look at another proof. Number 6, JN and KM intersect at L. KJ is perpendicular to JN, and MN is perpendicular to NJ, and we want to prove the triangles are similar to each other. So again, I've already gone in and wrote my givens here. I noticed that the givens tell me I have intersecting lines, so that tells me I'm going to have vertical angles. So I know these angles in the middle here I'm going to end up talking about. And I also know that I have perpendicular lines, and that's going to be right angles. Perpendicular lines form right angles, so I know I'm going to be talking about that in my proof. If you look at what I marked off in the picture based on reading those givens, there's my angle-angle similarity. So you could talk about the vertical angles first or the right angles. It doesn't actually make a difference as long as you do both. So I'll just do the vertical angles first. So angle JLK and angle NLM are vertical angles. And that's because intersecting lines form vertical angles. want to make sure that my proof is clear that those angles are congruent though. So I'm adding an extra line where I say they're congruent because vertical angles are congruent. This process that I'm doing here on lines 2 and 3 is very similar to the process in the previous question when we talked about the corresponding angles. And it's very similar to what I'm about to write about the right angles. So I'm going to say that angle J and angle N are right angles. That's because perpendicular lines form right angles. And then I'm going to say they're congruent because all right angles are congruent. Right? Every right angle has a measure of 90 degrees, so they're all congruent to each other. Well, it looks like we have angle here now, so I'm just going to write my proof statement that triangle JKL is similar to triangle NML, and that's by angle similarity theorem. So these two proofs so far, 5 and 6, they're similar to one another in the respect that both of the proof statements are about the triangles being similar. In the next two problems, we're going to look at some different proof statements, but the basis of the proofs are the same. We still want to prove the triangles are similar by angle. It's just sometimes we're going to have to add on at the end. All right, so let's look at one of those problems. Number 7. AB and ED are parallel to each other. AE and BD intersect at C. And notice the proof here now is showing a proportion. Well, let's think about what we've been talking about with proportions. We know that when triangles are similar, the corresponding sides are proportional. So that's what we're going to have to talk about at the end. But let's start at the beginning. We write our givens, and then we talk about what can we elaborate on in these givens. Well, if I have parallel lines, I can talk about in this problem the alternate interior angles. A little different than question 5. We have alternate interior here. And then the intersecting lines is the vertical angles, just like the previous question. So I'm going to write all of this out. I'm going to say that angle B and angle D are alternate interior angles. You could have also selected angles A and E, or both sets. That would work. And our reason, remember, is always explaining how we know that. So I'm going to say parallel lines cut by a transversal form alternate interior angles. Lots of writing in these proofs when you're talking about the angles. Then I'm going to say those angles are congruent because alternate interior angles are congruent. And now let's repeat that process in lines 4 and 5, but talking about the vertical angle. So I'm going to say angle ACB and angle ECD. At C, I don't have one single angle in the picture. There's multiple angles at that vertex, so that's why I'm using 3 letters now. So I'm going to say our vertical angles. The reason is the same as the previous question. Intersecting lines form vertical angles. By the way, if you happen to do both sets of alternate interior angles, if you did B and D like I did, but also A and E, you don't have to actually talk about the vertical angles because you would already have angle. And now I'm going to say those angles are congruent because vertical angles are congruent. All right, so if you look at your picture and you look about what we've written in the proof so far, we have angle. Ignore this current proof statement for a second though. Right? Don't worry about that there's a proportion here. Let's prove the triangles are similar by angle regardless. So I'm going to say triangle ACB is similar, just watch your symbols here, to triangle ECD. and that's by angle-angle similarity theorem. You might remember that a proof is always going to end with whatever that proof statement is. So here's my proof statement. AB over ED is equal to AC over EC. Well, if you look at those sides in the picture, AB and ED are corresponding sides. AC and EC are corresponding sides. And if we know these triangles are similar, those corresponding sides must be proportional. And that's exactly what we're going to write. We're going to write corresponding sides in similar triangles are proportional. And this is that abbreviation. At the start of the video, I briefly mentioned it, and I said we would come back to it. That's that abbreviation CSSTP that you could also use here. Okay, corresponding sides of similar triangles are proportional. All right, everybody, let's look at one last proof, and we're going to change that proof statement again to something different. All right, so let's ignore the proof statement, though, and let's just do our angle-angle proof like we know. All right, this looks like the first picture, the first proof we did, except it's just upside down. So I have corresponding angles, pick a pair of them, and I have reflexive property. So let's start with the corresponding angles. Angle CBA and angle EDA are corresponding angles. Hopefully we're noticing a lot of the repetition in the concepts talked about, and that's because parallel lines cut by a transversal form corresponding angles. Then we are going to say those angles are congruent to each other. And that's because corresponding angles are congruent. Then we've established in other questions, we're going to talk about the reflexive property here. So angle A is congruent to itself by the reflexive property. All right, so I can see here that these triangles are similar by angle-angle. If you need to separate the triangles, remember we talked about that before? If you want to separate them, again, don't worry about drawing it accurately. Just copy the labels of each vertex over. Okay, if you want to separate them so that it's easier for you to see the angle-angle, that's absolutely fine. So here's an example of that. And now I'm going to write that triangle CBA is similar to triangle EDA. Again, watch your symbols because we have been doing congruent so far, but the triangles are not congruent, they're similar. And that's angle-angle similarity theorem. All right, now we finally have to deal with this proof statement. So every proof, get the triangles to be similar, then deal with whatever variations the proof statement might hold. This proof statement is saying that AD times BC is equal to AB times DE. So I want you to think to yourself, when have you done multiplication in anything with similar triangles? And hopefully you're going to say to yourself, well, we cross multiply when we have similar triangles, right? If I had given you, I'm going to come up with a very basic example here, but let's say that this was 2 and this was 3 and this was 4 and this was x. We could write a proportion, and then how do we solve that proportion? We cross multiply 2 times x and 3 times 4. This is the process we're going to do in this video. We're going to write the proportion, and then we're going to cross multiply it. So based on that idea, if I go back to my proof, I'm telling you that you're actually going to have 2 more lines. We need to first get the proportion, and then we have to cross multiply. What I like to do on this question, I know this might look a little strange, is I like to put the proof statement in last, or I put it in its place. So AD times BC and AB times DE. I like to fill that in. We mentioned before that proofs always end with the proof statement, so I want to put that in, and then we'll talk about how we treat this as cross multiplication. All right, now let's go to statement 6. Let's go back for a second. We need to write a proportion so that we can cross multiply. Well, the proportion should have 4 elements: AD, BC, AB, and DE. Okay, we want to make sure that when we cross multiply, AD and BC get multiplied. Well, that means they have to be diagonal from one another. You can put them in this diagonal like I have, or the other. And I want to make sure that AB and DE get cross multiplied. So look at your proportion now. Cross multiply it. AD and BC get multiplied. AB and DE get multiplied. And that's what we get for our reason, or statement, in number 7. All right, let's think about what we're going to put for our reasons. For 6, those are corresponding sides of similar triangles, and they're proportional. So I'm going to use our abbreviation like the previous problem. You could write the whole thing out too. Corresponding sides of similar triangles are proportional. And finally, we're saying in 7, how do we know that these products are equal? Well, that's simply because cross products of proportions are equal. So my point to you on all of these proofs is this: get the triangles to be similar. Make that your main focus. Then deal with the proof statement. Okay, so don't let the proof statement distract you at all. Once you have your triangles similar, decide, do you need to just write a proportion, or do you need to do the proportion and actually cross multiply? Okay. Hopefully this video helped you understand a little bit better about similar triangle proofs. I know that they could be tricky, but again, focus on getting the triangles to be similar. Make that your main goal when you're working through one of these proofs. Thanks for watching, everybody.